Hello friends, welcome to my new data structures and algorithms in Java tutorial series video. Friends, in this tutorial we will discuss bottom-up re-epify in max heap. So friends, in our previous tutorial we saw the initial implementation of a max heap in Java. Now in this tutorial we will actually discuss what happens when we insert a particular element into this max heap. So here you can see that a max heap is a complete binary tree in which each node value is greater than or equal to the values of its children. So here you can see the node having value as 9 has two children 3 and 6. So 9 has a value greater than both 3 and 6. And similarly, if we take a node having value as 3, it has two children 2 and 1. So both these values 2 and 1 are less than 3. So here you can see in max heap each node is having value greater than the values of its children. So friend, this property is called as heap order property of a max heap, that each node value is greater than or equal to the values of its children. So friend, let's suppose we are given a particular max heap having these 7 elements. Now let's suppose if we insert any particular element into this heap. So after inserting that particular element into this max heap, it may not satisfy this above property. So friend, let's suppose we are given any particular max heap having these few elements. So in this max heap we know that the maximum value is always at root. So friend, let's suppose if we insert an element into this max heap having value greater than 9. So friend, as we discussed that heap is a complete binary tree, and here you can see all the levels are filled. So when we insert a new node, it will be inserted into this level 4 to the left of 2, and let's suppose we insert a value of 15. So once we insert this value as 15, the heap order property which we discussed, that each node value should be greater than or equal to the value of its children, will break, because 2 will be parent to 15 but its value is lesser than 15. So it will break the heap order property of this max heap. So friends, what we do is after inserting that particular value, we perform bottom up re-epify technique. So in this technique, what we do, we simply adjust the location of elements so that it satisfies this heap property. So friend, let's see a demo that how we can perform bottom up re-epify in a max heap. So let's say we are given this max heap having 7 elements, and let's say we insert 10. So here you can see all the levels are filled completely, and as heap is a complete binary tree, the value 10 will be inserted to the left of 2 at level 4. So it would look something like this, because in a complete binary tree all the levels are filled completely except the last level, and the last level is filled in such a way that leftmost side is not empty. So 10 will be inserted to the left of 2. So friend, as it is a max binary heap, we know that the maximum element always lies at the root of this binary tree. But here you can see, as we have inserted a value 10 which is greater than 9, therefore the heap order property is not being satisfied, because as we discussed that each node in a max heap should have values greater than the values of its children. But here you can see, if we compare 2 and 10, then the value 2 is less than 10, therefore it is breaking the heap order property of max heap. So friends, in order to satisfy the heap order property of this max heap, what we do is we simply adjust the locations of these nodes such that heap order property is satisfied. So here you can see, as 10 is greater than 2, so what we do is we simply shift up the value 10 and we swap it with the 2. So it would look something like this. The 10 is swapped with 2. So friends, once we swap this value, we know that 10 is now greater than 2. So at this position, 10 is satisfying the heap order property of this max heap. But here you can see, after this swap, we simply traverse to this node, and then we again see that whether it has any parent or not. So here you can see 10 has a parent whose value is 3. So then we compare these two values, because here you can see 3 is less than 10. So still the heap order property is not being satisfied. So what we do is we simply shift up 10 and we swap it with the 3. So it would look something like this. So value 10 is being swapped with 3. So once we perform this swap, we again traverse to 10 and we check that whether it has any parent or not. So it has a parent. Then we compare the parent to its children. So here we'll simply compare 9 and 10. So here you can see the value of 9 is less than 10. So still the heap order property of this heap is not being satisfied. So what we do, we simply perform a shift up and we'll simply swap these two values. So friends, once this swap is done, we simply traverse to 10 and we again check whether it is any parent or not. So here you can see that 10 doesn't have any parent. Then we also see that heap order property is satisfied because the root has the maximum value among the other nodes. Now friend, let's suppose we want to insert a value as 8. So as it is a complete binary tree, the other value will be inserted to the right of 3. So we simply insert 8 to the right of 3. So after we insert this value 8, we simply compare it with its parent. And here we see that 3 is less than 8. Therefore the heap order property is not being satisfied. So what we do, we simply perform a shift up and we simply swap these two values. And once we perform this swap, we simply reach to 8 and then we again compare it with its parent. So here 9 is greater than 8. Therefore the heap order property is satisfied because in max heap the value of parent should be greater than the value of its children. So 9 is greater than 8. So therefore the value 8 is at its correct position. Moving ahead, friends, in our upcoming tutorial we will see that how we can insert a value in max heap, and we will see the demonstration of the code step by step. So the example we will take in our upcoming tutorial will be like this. Now let's suppose the max heap is empty. So first we are inserting 4. So as 4 is the only element into this max heap, therefore the heap order property is maintained. Then we insert 5. So as level 1 is filled completely, 5 will be inserted at level 2 to the left of 4. Because we know that max heap is nothing but a complete binary tree. So 5 will be inserted to the left of 4. So once we insert 5, we will simply check its value to its parent. And as it is a max heap, we know that each node is having value greater than the value of its children. So here we simply compare 4 and 5. And we know that 4 is less than 5. Therefore the heap order property is not maintained. So we'll simply shift up 5 and we'll swap it with the 4. So now 5 is at correct position, and we know that among these two values 5 is the largest value, which is at the root of this binary tree. Moving ahead, let's say we insert 2. So 2 will be inserted to the right of 5 because left is already occupied by 4. So once we insert 2, we'll simply compare the value 2 with its parent, and as 5 is greater than 2, therefore it is satisfying the heap order property. Now let's say we insert 6. So here you can see the level 2 is filled completely. So now 6 will be inserted at level 3 to the left of 4. And then we'll compare these two values. And as 4 is less than 6, therefore we'll perform a shift up and we'll simply swap 6 and 4. So once we perform this swap, we'll reach to this node and then we'll again compare it with its parent. So here now we'll compare 5 and 6 and we know that 5 is less than 6. So we'll perform a shift up and we'll simply swap these two values. So friends, here you can see 6 is at its correct position because it is the largest value among the other three values. Now let's say we insert 1. So 1 will be inserted to the right of 5 and then we'll compare it with its parent. And here we can see that 5 is greater than 1. So no swap will be done. And let's say we insert 3. So now 3 will be inserted to the left of 2. We will compare 3 with its parent whose value is 2. And we know that 2 is less than 3. Therefore we'll perform a shift up and we'll simply swap these two values. And also friends, then we'll compare 3 with 6 and we know that 3 is at its correct position, therefore no swap will be done. So friends, this is how we perform bottom up re-heapify in order to maintain the heap order property of min or max heap. So friends, usually in most of the cases, whenever we insert any new value in an heap, the heap order property breaks. So after inserting a new element, we simply perform a bottom up re-heapify technique in which we simply change the locations of the element so that they maintain a heap order property. And we also give different names to this technique. We call it bottom up re-heapify. We also call it shift up. We can also call it swim, because the elements usually swim from bottom to top when we insert a new element. So in our upcoming tutorial, we'll actually see the code to insert an element into a max heap and we'll look the demonstration of that code step by step. I hope you like this video. Thanks, have a nice day.